Everyone. This is Dan Jarvis with Groundwater Protection Council. Thanks for attending our fourth in a series of webinars. Today's topic will be Area of Review and Zone of Endangering Influence, provided by ALL Consulting. Dan Arthur, the president and principal engineer, and Tom Tomasic will be giving this. So just before I turn it over to Dan, if you have up at the top of this Teams, there's a chat and a Q&A. If you have questions, please put them in the Q&A and not the chat so that I can monitor them. Tom will answer questions if he can, and then we'll have a Q&A at the very end of the seminar. Go ahead, Dan. I think you're ready. Go for it.
Super. Well, first, thank you everyone for coming to our fourth webinar. These have been, I think, very positive. We've gotten a lot of really good feedback. I think this one will be, I feel, as the most significant one that we've done so far because of the significance of area of review and zone of endangering influence. But within that, please know that GWPC is recording the event, and I think they're going to send it out to everyone. I will also be posting my slides from this on my LinkedIn profile. If you are not, connected with me on LinkedIn, I encourage you to do so and ask that you do. I try to put quite a bit of stuff out there on a variety of topics. So, look for that there. On the last slide, I do have a connection that shows my LinkedIn definition or whatever you call it, but nonetheless, that's there. Before we get going on the presentation, I want to also make a note that part of what we're trying to do here in these webinars, and we've really tried to focus on the Class II UIC program, but a lot of this stuff applies across classes, obviously. But we're also trying to pull in some history, some information that may be a little out of the ordinary, resources that can be pursued if you're looking at this, and just from a context perspective, Tom and I have been doing this for decades now. So, I started with EPA in the early 1980s in the UIC program. And we had direct implementation states of Indiana and Michigan, and did other stuff in other states, but went through with the national MIT work group, the National Technical Committee, all sorts of different things from mid-course correction, and then implementing a lot of these things that we're talking about, and working with states and the Robert S. Kerr Research Lab and so forth. So part of what we're also trying to do in this is give you guys a little history and context that may not be as apparent as might seem. I will also say this one thing as a preliminary note, and then I'll get started. But things like area of review and what we're doing and especially in the Class II UIC program change. I can tell you that in the early 1980s, a high volume injection well was maybe 5,000 barrels a day. And that's nothing, just with what we're doing with unconventional development and high volume hydraulic fracturing and flow back and produce water and so forth. The game has changed. And I know I was at the IOGCC meeting, not too long ago, talking with some of the folks from different states, and like the Railroad Commission, and it's interesting that we're having to do things very differently today than we did 30 or 40 years ago, especially when the program just got started. So keep in mind that is the case, and in the regulatory environment, and many of you are regulators, you understand that regulations and regulatory bodies are generally reactive. So I recall when we were pushing forward with high volume hydraulic fracturing and frac focus and all those things, you couldn't expect, say, a regulatory group to just anticipate how the fracking boom was going to explode and that we need regulations to address things. So this is not dissimilar with that in any way. And I think that things like, area of review and area of review analysis and the use of ZOE, and as well as the other thing that's going on in a lot of states relative to idle wells, marginal wells, orphan wells, just there's a lot of things I would say that a lot of regulators are having to deal with today. So just be cognizant that things change. They're always changing. They've been changing for the last 40 something years that I've been engaged in this. And I permitted my first Class II injection well in 1981. And let's just say that things are a little bit more intense today than they were in 1981. So with that, I'm gonna start the slide deck. Please, like as Dan Jarvis said, if you got questions, put them in the Q&A. Tom will try to do that. We'll have a question and answer session at the end, and I'll try to get through this as quickly as I can. But my contact information, Tom's contact information will be at the end. So if you've got questions, just feel free to reach out. Okay. All right, here we go. So Class II UIC webinar number 4. This is our last in the series. And as I noted, we're really trying to focus on Class II wells here, but keep in mind that the things that we're talking about will apply to other well classes. So one of the things that I really wanted to stress for today, and I think people realize it, but the area of review analysis when it comes to permitting a Class II injection well, or really for any injection well, like we could talk Class 6 wells or Class 1 hazardous waste injection wells, area of review is critical, and understanding the basis of it and so forth is a really big deal. I've been on countless situations where injection from Class II wells occurred and there were problems. I can think back to one in Posey County, Indiana, when a shallow water flood was started up, and we at EPA got a call that from a farmer who was watering his crops, and all of a sudden all of his irrigation was coming out as oil. So, you don't know what the issues are. In that case, there was a whole bunch of old, unplugged, orphaned wells right in the vicinity that were undocumented. So really understanding what's going on, where things are, and so forth is key. But the area of review analysis, really led by its base, that zone of endangering influence, is critical. I saw Mark Lane on here, and we were looking at permitting Class II wells in Appalachia years ago and running the zone of endangering influence. Depending on the zones we were in, you could have an area review of 5 miles for a Class II well. So it really just depends on the geology. You have to know what's going on and all that. But AOR analysis is critical for, one, assessing feasibility of a new proposed well, planning for it, designing, assessing potential corrective action, and ultimately assuring that you're not affecting, or negatively impacting an underground source of drinking water, which is really if we look at the UIC program, it's part of the Safe Drinking Water Act. So this is really the true basis of this. So whether it's Class II wells looking at protecting, underground sources of drinking water, or Class 6 or Class 3 or Class whatever, these things still come into play. And although it's, like well design is critical, mechanical integrity is critical, the AOR assessment is in my opinion, is really the cornerstone of the UIC program, because, some places aren't appropriate to put a well because of the geology, or you've got to do a lot of, corrective action in there, or you have a lot of unknowns, or you have poorly plugged wells, and it could be all sorts of things. It could even be the construction. So when you look at that, you've got to understand the wells that are in the area, maybe what their condition is, how the producing wells were drilled and completed and cemented, and what the geology is doing, and potential underpressurized zones, overpressurized zones. One of the things that we're getting pulled into a lot today is not only looking at potential impacts of injection wells or Class II injection on USDWs, but the potential impact of Class II injection wells on producing wells. So we also want to be cognizant that a lot of injection wells were converted production wells, and so we've got to look at all of the key aspects of this to make sure that as we're doing our work, our planning, our feasibility analysis, and so forth, and as a consultant, sometimes we have to tell our clients, like, this is really not a good place to put this well because of whatever, or we can put it here, but we're going to have to do a bunch of corrective action, or, it could be a variety of different things. So what I'm saying here is be cognizant of that, and I'm telling you, this is how we do this. And if you look at this figure here, sometimes we get into places where we may put a well and there's more than a well or two within a relatively short distance of a proposed injection well. So that means before we can really, push forward, we've got to look at every one of those wells and make sure that there's not mechanical problems, completion problems, cementing problems, all these different things to work through. And it can be a chore. So it's complicated. We'll go through some of this to the best I can. I'm going to warn you here as I push forward to this next slide. I've got several slides in the deck. They're going to be available on my LinkedIn profile. I'm not going to read word for word, especially when we talk about some of the state cases. So I'm going to put some burden on you to try to move forward and work through these. If you want to study the slides in more detail, they'll be available. So some of the common challenges of this, incomplete well records. We've done a lot of work with, doing area of review analysis, and we wind up getting to areas with wells drilled in the late 1800s, early 1900s. They're not always complete data sets. I'll also say that, when you look at, say, a well drilled in 1900 or 1930 or something, a state is maybe taking a section township range and putting in their database where, somebody sitting at a desk is converting that to a latitude, longitude. And that may not be exact. We've gone through multiple land grid updates over the years. So make sure that when you're looking at this, that you confirm the location of wells, that you are doing your homework and not just trusting, a database. I can tell you an example of this in the state of Montana. We went to permit a well. We looked at the databases and so forth, and sometimes these lessons that you learn aren't necessarily lovely, but we go out there, and it was on federal land, so we had to meet BLM out there, and we get out there, and a well that was supposed to be 2 miles away was about 100 feet from our proposed location. And I still remember Jim Halverson, who was the geologist at the Montana Board of Oil and Gas Conservation, and another gentleman friend of mine at the BLM looking at me like, so you trusted that database, huh, Dan? And so anyway, make sure that you confirm. I'll also say that, you know, when we look at high well densities and mature fields, complex geology, you know, that those zone of endangering influence calculations can be a challenge. And, you know, like if you look up here just in Osage County, we may have formations that have 40% porosity, but 1% permeability or something. And so we've got to look at a lot of details because we tend to assume things in equations that things are consistent and normal and all that, but oftentimes they're not. The other thing that we're seeing is in a number of areas, if you talk to the Corporation Commission here in Oklahoma or the Railroad Commission, we're seeing and have, you know, historically seen a number of purge cases, water coming to the surface. Fernando de Leon, you know, is, you know, with ALL Consulting as former Railroad Commission engineer. There's been several cases over the years where, you know, injected fluids would come up annular spaces in producing wells because they weren't cemented as they were anticipated to be and cause problems. So there's a lot of things that we need to be, you know, cognizant of, is just, you know, the potential purges, fluid migration out of zone, seismic events, you know, all sorts of different things. So, you know, I'm just be cautious. So now we're going to talk about, you know, what is area of review in ZOE. I put up a few documents here because what I'll say is there's a lot of early research work that has been done at EPA, at UIC, or, you know, our GWPC, formerly the UIPC, you know, and in a variety of different people. This middle document was a guidance document that we had engineering enterprises do for EPA. They were I think they were the first EPA contractor to the UIC program. And, you know, we did a lot of things. There's, you know, there's people on the call now that are no longer with them, but, you know, can remember back to those days. And I'll also note that GWPC has a library with so much of this stuff in it. If you're ever really looking to go find that stuff, they're a great resource. So area of review, you can have, you know, I'm like I said, I'm not going to read these, you know, word for word here, but you know, primacy states for Class II do have fixed radius AORs. It's typically been a quarter mile, could be up to 2 miles, but it has changed over time and is changing, I would say, right now. But there was even a point in time where, as part of a U.S. Department of Energy contract, that at the time Bill Hawkeiser was working with us on, and he left DOE, came to work for ALL, and he's retired now. But that was a point where we were actually working with DOE, and the states and industry was pushing for AOR variances because they're saying this is just too expensive. It doesn't really accomplish anything. And we did a lot of stuff in that with RBDMS and within various states. Morse Corpage, the former Kansas Corporation Commission oil and gas director, did some stuff. We worked with them, but I'll say that, you know, things were different then. That was really when we're looking at, you know, conventional marginal production and so forth, and things have changed now. So the idea of AOR variances, I'm going to guess, would not go too far in today's world. And when we look at these investigations of AOR, you know, it's really this basis of the zone of endangering influence, which you're really looking at. You want to make sure that, if there was some, how we looked at it back in my EPA days was if there was some unknown, you know, unplugged well or geologic feature, that, what distance from the well, would be the limit of where injection fluid buildup in the injection zone, if there was a pathway, could move up that pathway and overcome the hydrostatic head of the lowermost USDW. And so when we look at that, it can get rather, complicated, because you could look at a number of different features, but this exhibit that we have here, it could be a number of deals with, mechanical integrity or well integrity, or, internal, external integrity, or a variety of things. But what we're really looking at is that idea of that distance, and controlling that. And I'll also say that, the whole idea of area of review and that zone of endangering influence, you can look at and find a number of different things. This one is actually an example of CO2. So not a Class II injection well, but it's a good depiction of this and some of the extreme concerns. The picture to the right is a picture out of a document called Tulsa's Physical Environment, published by the Tulsa Geological Society in 1971. And it's one of many pictures where researchers, geologists at the Tulsa Geological Society were going through a variety of different things of wells in the region, and how they could be set up to allow for contamination, whether the wells maybe weren't cemented properly, whether they were cemented at all. We used to plug wells back in the day with brine, or a piece of wood. As Tom will tell you, we've had multiple different things where, if you look back historically, some of the industry practices for well plugging included and specified using wood plugs. Things have changed a little bit, but we have to be cognizant of our history so that we know what we might expect depending on the types of wells we run into. And we also have, EPA requirements on this, and EPA has done quite a bit here. We looked at back in the 80s, when the program was first being developed, that quarter-mile area of review base, that you couldn't get smaller than that. And in reality, at the time, back then, that was more than enough. But we were looking at a lot less injection volumes and so forth. And I can tell you, I can remember when I was working on the Class I hazardous waste rules, the land ban rules, and we did 2-mile area of reviews for Class I hazardous waste injection wells. And that was difficult because we were proposing a much more significant area of review, and a lot of the industry, a lot of the people that we got comments from were saying it was just ridiculous. And today, I think I think we get the idea that it's better safe than sorry, and there's a whole lot of things that we want to consider. And it's also difficult to note that, is that fluid going to migrate, uniformly, or could there be preferential flow paths, or whatever? I can tell you, I can remember doing a hydraulic fracturing job, and this isn't Class II injection, so forgive me, but this was a hydraulic fracturing job in the state of Montana, in the Bakken. And this is when they were doing single stage frac jobs where you drop balls in there and to try to get things to work. And that was a terrible idea, but that was the technology we had at the time. And 15 minutes after initiating a frac job on a well, a well a mile away blew out the stuffing box from our frac job because there was a direct pathway. And those are hard to find, but having that information and that also suggests the significance of monitoring and so forth. So history of the area of review process, like from the 80s, really fixed radius, you had, Department of Energy research, EPA research. There was just a lot of things going on over the years. In 93, new Class II UIC programs are being considered that require AOR evaluations of at least some of the grandfathered older wells to be updated, because a lot of those early injection wells when we started the program were permitted by rule. So it was a very different time, and then the UIPC, now the GWPC, got together with API and EPA and a number of different folks and looking at a variety of different things on AOR variances and applicability of zone of endangering influence and how you do that, and if any of the things that needed to be redone. So there was really a lot of work going on then, and a lot of resources that are still out there today. And this is a very simplistic graph made by two of my friends, Steve Platt and Dave Reckenwall, former EPA Region 3 guys. I'm sure many of you know them, but in this article that they did back in 2005, one of the things that they were noting is that when you have that fixed radius area of review, you really still need to look at that zone of endangering influence, because there could be times where, depending on where you're at in the situation, your injection volumes and all that kind of stuff, where the zone of endangering influence could show that it's greater than your fixed radius AOR. So really your AOR needs to be larger than the fixed radius. And they made some really good points. I encourage you to look at that article if you can. They did a really outstanding job. So, and then when we look at this, zone of endangering influence, there's a number of details that you go through this with the Tice equation. And, this is something we put together back in, 2016 on some calculations for, actually, permit application and looking at that. So this just kind of gives you this basis, but, I would say that to all my geologist, reservoir friends that are on the call, you really need to understand the geology, the hydrogeology, the history of the area, and all those things, because you may need to take a look at this and go, hey, there's some things in here that within this calculated zone of endangering influence that might influence what this is, and maybe we need to increase it. Maybe we need to keep in mind that there could be that we got to send people out to look at things on the ground to affirm that there's not wells where we don't know about. So just lots of things to think about and consider. And so this is some of the assumptions, with the zone of endangering influence. And my point in this, in looking at it, is some of you can look at this and go, well, most injection zones aren't homogeneous, for instance. So, but like looking at that geology, studying the geology in the area, downhole logs, all those kind of things, you can get some really good ideas on how this might change, how it could evolve, all sorts of different things that can be critical in your analysis, and making sure that, if you're going to plan an injection well there, you can go, hey, there's some things that we don't know about. If we move it a mile this way or a mile that way, we don't have to deal with a potential problem, So there's things that go in that feasibility, that planning, that are critical, that these kind of analyses can really help you with. So the other thing that, and we're gonna I'm already at 12:30. We're going to go through these pretty quick, but requirements can vary by state or regional area within a state. And my biggest point here, and I've talked about this a little bit, is we have to be cognizant of the fact that, you know, that the UIC program isn't just, there isn't one set of rules that's applicable to every state, everywhere, and all that. If you've been part of, GWPC or IOGCC over the years, this is the same thing with oil and gas development. The states are different. You want to go try to, drill a well in Alabama versus Alaska, or, the LA Basin versus, Pennsylvania. They're different, and we have state agencies that recognize those differences, and the rules can be a little different by state, by maybe region within a state. So don't make the fatal flaw that maybe you permitted a well in Eastern Oklahoma, and now you're going to go to the LA Basin and you just do the same thing. They're different. So just keep in mind what's going on, what the issues are. And it's the same thing like this example from LDNR is good, because we've talked about, AORs and Zone of Endangering Influence. And I can recall back on the Cedar Creek anticline in Montana, we converted a major water flood from vertical water flooding to complete horizontal water floods. So when you look at the difference of doing an AOR, for a vertical well versus a horizontal well, or multiple horizontal wells, it can be very, very different. So I would just say, make sure that you understand this. We have a lot of regulators on the call. Coordinate with your regulatory people. They're generally, everywhere I've been, they've been very helpful. So you have options. Don't do that silly thing that some of us do sometimes, is assume we know. Figure it out, dig into it, and get help if you need it. So this is like what we're going to go through now, and I'm going to go through this pretty quick and leave a lot of this to you guys if you want to look at this going forward. But this is kind of, I wanted to have something in here where we show that, there are variations between the states. So, several states have, specific things, but, you have different states that have kind of, their own unique rules on this and how they're permitting or guidance and so forth. And there's recently been stuff come out in the state of Texas. So be aware, don't assume. So within this, I'm gonna go through these few examples here pretty quick, and then we'll move on to the next thing. So Kansas Corporation Commission, fixed radius, quarter mile, but there could be variations there within that. Uses zone of endangering influence calculation only as a method to define the AOR if it expands the quarter mile radius. So again, even in Kansas, you can see areas where a quarter mile, depending on what you're doing, may not be enough. So you've really got to look at that, coordinate with the agency, and go from there. Louisiana, conducting a foot search of the AOR to identify wells in the field, searching using their databases and all this. But this is significant, because like the example I gave you earlier of my poor assumption, trusting the location on a database was something that taught me a lesson. And I was recently also in some litigation out in California in Marina del Rey, and for a well drilled in 1930, there'd been multiple land grid changes since then, and the location of the well was a little bit different than they had anticipated, caused some big problems, and the people that were doing the work didn't realize that the data there wasn't perfect. So I'll just say we've learned a lot, and you got a lot of old maps and all that, but I'll say sometimes even the old maps, the new maps aren't always accurate. So, I've given this example in other cases, but earlier in the oil and gas industry, somebody might drill a well, find a gusher, have to report it to the state. They'd report it in even another county so that they didn't have a bunch of other folks come in there and beat them to leasing the minerals out. So, you know, make sure that you know the data and that you go from there. So New Mexico's got, change the requirements for deep SWDs, so looking at that, there's a lot of things that I would say that New Mexico worked on relative to induced seismicity, as has Oklahoma and Texas. But within that, there's ongoing changes in New Mexico with different rulemakings that's going on there with idle and marginal wells, and it's an ongoing thing. So I would say keep abreast of the changes in the areas that you're working on, and I encourage you to be engaged in those rulemaking modifications because they're constant. North Dakota, I don't know if we have any NDIC guys on here, but use that fixed quarter mile AOR. I will say that when you look at this, the primary injection zone for disposal in North Dakota is the Dakota Formation. And back in my EPA days in the early 80s, we worked with the North Dakota Industrial Commission to do a regional aquifer exemption. And so maybe that's that might be a little different than what we're talking about on AOR, but you have the Fort Berthold Indian Reservation there as well. So you could have areas where you may have a well that's let's just say drilled into the Dakota, which is an exempted aquifer, but maybe you're right next to the reservation. But on that reservation, that's a USDW. So you have to look at this from a lateral perspective too, and those considerations can be huge. So I'll give you another example, and this is for Class I injection, but was in Florida injection in the Florida aquifer, because you had one area of Florida where we were injecting treated wastewater, but miles away that water was being used for fresh water supply. So sometimes, you not only have to look up or down for a USDW, you have to look laterally. So there's so many things to keep in mind. State of Ohio, different rules, like some passed in 2022, looking at, allegation of injection migration beyond even a half a mile. So there's a lot going on there. I will say that, we've also seen a lot of concerns in states like Ohio and Texas and New Mexico and Oklahoma of potential of injection wells also impacting production or wells that where maybe the records weren't complete or weren't accurate for area producing wells. But you can see when you start looking at some of these areas, the number of wells in the regions can be significant. So it's a lot to consider. State of Oklahoma, typical AOR radius is a half mile. We've done some of these wells in this where, one well for a quarter mile, you could have 150 old wells that you have to go through in a very small radius. So, when you look at understanding the history of some of the areas, understanding that is significant. And also, like I would say before, we've in Northeast Oklahoma, this is kind of, where a lot of the folks that were, early developers in Appalachia, they moved to kind of Oklahoma and Kansas and really started pushing the production there. But we have a lot of orphan wells. We have a lot of wells when the practice back then was to plug with brine or not plug at all. And many of the wells don't have casings and so lots of things to consider. And so understanding that history too, and the area that you're in is just huge. And Oklahoma, again, you know, really was impacted on injection because of the induced seismicity. So really trying to, permit new wells in formations like the Arbuckle can be a challenge. Not undoable, but it can be an issue. So both looking at the formations, so maybe you're moving up into shallower formations. So now you got more potential, things to consider. It gets complicated. Texas Railroad Commission, we put some things in here, kind of intentionally of where they were. But what I note at the bottom here is that, the Railroad Commission recently changed things on that apply to area review and permitting and associated things. So, make sure that you're following those regulatory changes. Wyoming, this was, went from something where, Class II disposal wells were regulated by the, Wyoming DEQ, and then the Wyoming Oil and Gas Conservation Commission, was able to take over that for the Class II wells. So it's, it made a big change in a lot of the work that we were doing, going from the DEQ to the WOGCC, and how those are handled and the permitting process and so forth. So just, another one where there can be some rather significant changes. So one of the last big things I want to talk about is corrective action. So there's so many documents out here that talk about this. I'll tell you that we've had to look at and consider and do corrective action a lot of different times. ALL Consulting, July 1st, we celebrated our 26th anniversary as a company, which I'm excited about. But we've permitted over 2,500 injection wells over that 26-year period. And there's wells we've had to get aquifer exemptions for, do corrective action for, all sorts of different things. And I'll just say, really understanding that and what you might have to do. And if you look at this center spot, this is a fault. So it's not where we're dealing with some old orphan well or something like that. You can have issues where there are known natural geologic pathways that you want to avoid, and sometimes those natural pathways are not located where you would like to have them, and because they're right where you want to do stuff, but they can cause a problem. So you may have no choice but to move or adjust your operations or whatever. So lots of different things to consider, but within that, it's like, as part of the permitting process, the person getting the permits got to look at, identifying those conduits, if is there corrective action that needs to be done? Are you dealing with wells that, in the area of review that, let's say, were plugged, but not plugged very well? Are you dealing with unplugged wells? Are you dealing with, you're maybe trying to move from a deep injection zone to a shallower injection zone, but now the producing wells aren't cemented through that zone. So there could be any number of different things that could be an issue. And again, like I noted, this is Will Green. He's on the call, and he's out in Eastern Ohio. But when we look at this, and you're permitting wells, especially in a number of places where you know there's been a lot of history of water wells and maybe gas storage, or pick any number of things. You've got to learn how to go find those wells, and sometimes you just need boots on the ground to get out there. And we certainly got more technology today with drones and all kinds of stuff, but still, we're not always trying to find wells for purposes of just, hey, we're on a state plugging program or whatever. These could be, we're trying to permit an injection well, and we need to know, are there wells here that we need to do corrective action for? So, some of those types of corrective action, they can really vary. I mean, I've talked a little bit about them, but they could be improperly plugged. Like, I think a thing that we're dealing with more today than we have in the past is because of some of the induced seismicity things, we're for wells, we're moving uphole to other formations. And so that sometimes those shallower formations have the potential to be more complicated, because there may be producing wells that go through that formation, or other historic unplugged wells, or any number of different things. So lots of things to consider. So closing thoughts. I know we're starting to run out of time, and I want to leave a little bit of time for questions, but fully understanding this AOR analysis process, including ZOE, is critical. These two things, can vary amongst, in my opinion, like the most significant parts of the UIC program, but they can also vary by every state, and we're dealing with a lot more things that have created more complexities with AOR and ZOE and all that. So, it's if you're doing things in a lot of areas, and you need to get rid of a lot of water, and your shallower formations and everything else, it's going through this process now for permitting is not just some easy peasy deal. So just keep that in mind. And it's better to do your work up front than, not go through all the details and find out you got problems later. And, there's a quote from Reddit Air that I love. And he says, if you think it's expensive to hire a professional, wait till you hire an amateur. So make sure you do the work that you need to do. And because to me, you're putting your technical and credibility on the line with a state, with everything else. So you may have to deal with protests and all that. So you need to be able to make sure that you've done all of your homework. And so that's the last thing here. This is mine and Tom's contact information. We've got our emails on here. That's my LinkedIn connection. Again, I'm requesting that, if you can, to, please, connect with me on LinkedIn, and I'll have the slide deck out on my LinkedIn profile probably tomorrow. So I'm going to leave this slide up, but I'm going to end the slideshow portion so that I can see some of this. So you should still be able to see the screen over there, but we'll go from there. So Tom, Dan, any questions?
Yeah, Dan, we've got one in the question answer. Lori wants to know, in the UIC Class II program, do applicants routinely evaluate the pressure impacts from other injection wells in the zone and the pressure magnification that happens when multiple pressure plumes intersect? And the second part of it is, what guidance would you give to the applicants' operators to address this?
So Lori is a pistol, and she's right on, because what we're getting now is an abundance of injection wells in various areas where there's a lot of unconventional development going on, especially areas like the Permian Basin. So within those, I would say that it is common to consider exactly what she said. I think that you know, the New Mexico OCD expects that and looks at that. But that's not, you know, it really depends on the situation. So you could be in areas where, you know, you're 20 miles from the nearest other injection well, and it's maybe not a big deal. So I will say that it's not always considered, Dan, but within that, I would say that, you know, when we're doing that, we're looking at what's in the area, what other injection is going on, and keep in mind, you know, this could be, you know, you've got to look at not only like say because her question is a little tricky because it's, you know, like other, you know, say two disposal wells in the area. Well, you know, we deal with some of these where you might have a nearby disposal well, but you might have a nearby, um, you know, well that's disposing of waste CO2 from, you know, from a plant, or you might have a gas storage field, or you might have, you know, any number of other things. So you really need to look at all those things as you do that. And I'll say this, the other thing is of historical production, because you may have zones where, you know, there's been a bunch of stuff that has been produced or whatever that you also need to just be aware of, you know. I don't know if I answered your question, Lori, but
Well, thanks, Dan. Laurie, I gave you the thumbs up, so I think you
okay.
did. Um, okay, we have a couple more. These are over in the chat. What is the approach, if any, to AOR ZOE delineation for wells near offshore where USD is not present?
So so I'd say that that there we have done stuff where you're in an area where there is no USDW or no known USDW. But I'll say that you also, like, if you look at, you know, you get out into, like, you know, around Galveston County, Texas, or something like that, you can be on the edge and it's just saltwater, you know, up there. But it can also get kind of complicated because there could be a lot of other things going on that you need to be aware of, and it's you can have some of those areas that are very faulted. So we got to be cognizant of surface water too, and what the connections might be. So you still need to be cognizant and looking at that, because remember, yes, it's a UIC program under the Safe Drinking Water Act, but you know, you don't want to permit a Class II disposal well where you're injecting and there's a fault, and now you're putting 150 TDS water that's impacting a lake, for instance. So it's you still want to follow those things and you know, look at this from a broad scope. I don't know. That's a hard question, but a good one.
Thanks, Dan. So let's see, we have another one here. Matt Bentley, he just says he'd like to thank you and say you've nailed it on the head with boots on the ground. Monitoring is crucial nearby production wells. These
Yep.
historical areas can be a nightmare for cementing and plugging, which is absolutely true.
Yep.
Um, is there any plan to utilize dynamic stimulation models to determine AOR rather than relying on a fixed radius AORs? Having hydrology or plume models before injection could provide more credible lateral distances for AOR?
So what I'll say is this is, you know, I talked about this from a base perspective, you know, with Zoe and all that. So others have used various types of models. So if you're in an area where, you know, the geology is very different, or it's stratified, or 100 other zillion things, you may need to get a model done and utilize that because just the base calculations are inadequate. But you need to do your research up front to really understand that geology. And I think kind of like what Lori talked about is what's going on in that area. I mean, if you're out in the middle of nowhere and it may be a little bit, but there's no water wells, or I don't know, you could think of scenarios that maybe it's just not justified. But in today's time, I would say, we run across cases where just doing the regular ZOE calculations and all that is inadequate, and you got to pull models in.
Thank you. Elise from Colorado, she said you spoke to complex geology early on. What guidance can you offer for disposal wells that are within a half a mile of producing wells in the same formation? Could ZOE be useful for showing that communication will not occur?
So if you're doing disposal in a formation that's that close to a producing well, if this is me, what I'm going to say, and if you are my client, I'm going to say, look, they're pulling water out over here, which is depressurizing that formation for you. The plume doesn't necessarily go in a circular thing that way, and it certainly doesn't always do that. So you could have some problems, and if you impact their production, they're going to sue you, and that's probably not what you want. So that's a tough deal. Can ZOE help? You could do a variety of different calculations, models, and so forth. But if you're a half a mile away from significant production, that's critical. And I would certainly be working with the production operator on that too. Now, by the same token, it may be not a commercial well. Maybe it's a disposal well operated by that company, and they're almost using it as EOR. So there's a variety of different situations where that can change and vary. So just having the understanding, the technical details, and all that, and recognize it, because I think you're asking that question, but you already understand the answer. So anyway, I got time for one more, Dan.
Okay, I think this one will be easy for you, Dan. David Cates wants to know, would you use the specific gravity of the formation or of the inject date in the ZOE calculation? And how do you determine the specific gravity for the injection zone?
So you guys love asking the intricate detail questions because it can be, it can really be significant. And I'll add to his question is let's say that you're a commercial SWD and you're taking production from an area where it's not just, say one formation. It's an area that's being produced from multiple formations. And sometimes, I mean, like when there's areas where I see water that's 40,000 milligrams per liter TDS to 20,000 milligrams per liter TDS that's produced water to even fresh, so like in eastern Montana, a lot of the production zones, the water there is like 6,000 or 8,000 TDS. I mean, it's the associated produced water, and other areas it's 80,000 or 150,000. So it's a tough question. So I think that those are things that you've got to account for, and maybe you do multiple calculations and then say, okay, when I look at this, it could be, 0.4 miles to 0.45 miles or something like that, and see how that does for you. But those are good things to make sure you're thinking about.
Thank you, Dan. Thanks so much. It was a really good webinar. Appreciate your time and the effort you put into putting this together. I'd like to thank the participants. We had a very high participation rate today. So this ends our CWPC's webinar series for right now, but stay tuned. We'll see what happens in the future. Thanks, Dan.
Thank you, and please connect with me on LinkedIn.